We are continuing connected particles. I hope you all have the worksheet that I've sent to you. And we have to continue questions in that worksheet, right? So let us go to that. The last question we were discussing, I think was it the second question? Good afternoon, Nathan. Second question. We completed the second question, right? Did we? Part one only, okay. Did I ask you to complete it for homework, Hatvi? Okay. So let us then go back to, go back to this question number 2. So you have to be in the question, you have to know what is happening. So if you can't remember, please read the question again. Let us refresh our minds about this question number 2 and continue doing part 2. Right? Give me a moment till I set this up. Right, so we have we did part 1, right? Part 1 only. We found the greatest value. Okay, so what's happening here now? There are two particles connected through, we are a string, inextensible string. It's going over a pulley that is connected to a ramp. One particle is resting on the ramp, the other particle is hanging down. As you can see, the particle Q is heavier than P. This ramp is rough. And if you release it as it is, the friction acting between P and the surface would not be enough to stop it from moving. And since the Q is heavier, it's going to start moving. Yeah, it's going to start moving towards Q if you just release it. So they say that you are applying a force X directly down the plane. So to stop it from moving, you have to pull on particle P, and we found the greatest value that external force P can be in order to keep this stationary. So we did that part. Then given instead, so the value of X was, it's given, it's a show question, 6.2. Greatest X is 6.2. Given instead that X is 0.8, find the acceleration of P. Right? So let's tackle from that part. I am going to redraw the free body force diagrams for P and Q. Yeah. So let me draw it, and shall I show you? Right. Oh, Umalia has already found the acceleration. She says it's 2. Let's say. Okay, is this too bright? Okay, I think now it's okay. Okay. Right. So here's your P. I will just draw part of the ramp just so that I know it's on this thing. Here are the forces acting on P. This is P. P's own weight acting down. 4 newtons. Reaction force, R. The angle here is alpha. And you have the external force X pulling down on P this way of 0.8 newtons. 0.8. Now tell me, 0.8, this external force is smaller than the greatest greatest force required to keep this stationary. Then in what direction is P moving? So it will not be still. It will move now. It will be accelerating in what direction? Up the slope or down the slope? You need to either talk or, looks like, oh, when I keep my hand, anyway. Now you need to quickly respond. This takes time. Hath is asking down, question mark. Hatfi, when you apply 6.2, it's trying to move that way, and it's trying to move up. Without any force, P will go up. That's clear now. And then to stop P from moving, the maximum force you need to apply is 6.2. When it is 0.8, it's smaller than 6.2. Did we by any chance, if you want, you can find the smallest force that you need. Okay, no need to go there. So if it is 0.8, then it would be trying to go up. It would be going up. This is not enough to stop it. So it will be going up. It will be accelerating upwards. So I will mark the acceleration with a double arrow, right? Then if it is accelerating up the slope, my friction would be in what direction? Nathan, friction would be in what direction? And is it maximum friction or some other smaller friction than that?
It's accelerating upwards. So, and there's a force acting downwards.
Is it max or?
Downwards.
Is it max or?
No, it's not max.
It's not max. How do we know it, Nathan?
Hold on. How do I say this?
Okay, let me correct you. It is F max, Nathan. It is if it is moving.
Sorry. I'm sorry. It's if it's at equilibrium or if it's moving, it's I get it. When it's about to move, it's always at F max.
About to move F max and moving F max.
Right? I'm sorry. It's just that
right, F max. Okay. Then is that all, or are there any other forces? Is that all, or are there any other forces? And here's Q. While I draw Q, tell me, are there going to be any other forces acting on P? No? No. And on Q, its own weight and the tension upwards, and that's all. It's just hanging, right? And it will be moving, accelerating downwards with the same acceleration. This A and that A are the same. They are connected and it's moving together. Like that, okay? So you just apply F equals ma to the two particles. So to particle P, I will do its working under that diagram. I will do the working for Q under that diagram. If you are doing like that, you don't need to say to which particle you are applying F equals ma. But if you are not doing like that, you need to say. So I will say it anyway. I will say for P. For P, I'm applying in the direction of motion F equals ma. F equals ma. It's moving upwards. It's accelerating upwards. F equals ma. So there are no forces in that direction. All the forces are in the other direction. So they're all negative. So I have negative 0.8, negative F max, negative or minus the component of my weight, that is 4 sine alpha is equal. So there are three forces: the external force, the friction, and the component of the weight acting parallel to the slope is equal to m.4 A. Okay. Now sine alpha, I think we found in the, if you can refer back to your previous work, they have given us tan alpha as 3 upon 4. So we found sine alpha and cos alpha from that. Sine alpha is 3 over 5. Cos alpha is 4 over 5. So I can apply it here. And F max I can quickly find if I, okay, wait. Now I applied F equals ma in this direction because in that direction, forces are not balanced, it's accelerating. But in the perpendicular direction, this way, forces are balanced. So if I do that, if I say that this way, that is equilibrium. Sorry. This way, it's in equilibrium. So condition, or you can just say equilibrium. Condition for equilibrium. Its forces are balanced. R is equal to 4 cos alpha. Okay, so this is what I can apply for P. Is that clear to you? Always, these are the things that you can apply. If it is accelerating, in the direction of acceleration, you apply F equals ma. In any perpendicular direction, it's not moving vertically. It's not going up or sinking down the slope, sinking through the slope into it. In this direction, it's not moving. So you can equal forces in that direction. So equilibrium in the vertical direction, F equals ma in the parallel direction. That is horizontal to the slope. Now we want to find a. Now you should be able to see now. I can use this equation itself to find a, because sine alpha I can put from here. F max I can write as mu r. R I found here. I can put it there. Oh, any forces missing in free body force diagram of P?
Yes, that one there should be a
The string is there, no? So tension is there. T is there. So T, there will be a T here. T minus all of that. T minus all the other three in the opposite direction. And that T you can find from, if you apply, let me separate these two, otherwise it looks like, okay. So if I go to now particle Q, I can only apply something in the vertical direction. It's accelerating. So for Q, I can apply in this direction F equals ma. Right? F equals ma. What do I get? 7 minus T is equal to 0.7 A. Right? Let me label this as 1, this as 2, and this as 3. By working on these 3 equations, I can find A. First thing I will do is, here I have just applied the formulas and conditions. Now, how am I going to manipulate these or use these with one another in order to get to my answer for A is something that you have to think. So I hope you can see that if you take this equation, the first one, you can rewrite number 1. Okay, T I don't know, T minus 0.8, but F max I can write as mu r. Mu is how much? Mu is how much? Did we already found? Did we find? Oh, it's 1. We have already found it, no? In the previous part, F max is 1.6. It's given? F max? No, we found F max. Yeah, mu is given, but I mean F max, we could have written it here straight away. I didn't have to. Shall I do it? Okay, it's okay. So let me just reuse it. F max is found in part 1. Go and see. We found it. Mu is 0.5 times 4 cos alpha. So it's 1.6. We have found it, 1.6. Then minus 4 sine alpha, 4 times sine alpha is 3 over 5 is equal to 0.4a. So you can see that there are only two unknowns, tension and A. Everything else become just numbers. tension and A. And then I have another equation with tension and A. So I can use them simultaneously to find A. So I'm not going to do the algebra of this, solving simultaneous equations. You have to do it and get the answer. A is, uh, how much is it? It is 2. Okay, so solve. If I call this 4, you don't have to keep labeling like this a lot up to 4. I think you could have just immediately put things here and used 1 and 2 then. But for me, I messed it up a bit. I will say solve 4 and that 3. I get A equals 2. Is this clear? What you have to
Yes.
learn, okay, what you have to learn in this, now I'm doing these questions with you, right? We have only still done 2 questions uh, 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 on connected particles. So it's okay if you are not fully comfortable yet, it's okay, right? So we'll do the third question also. What you have to pay attention is to how I go about solving these problems. Okay, I have given these guidelines in the note. I'm exactly following those. But if you have any question, if you want to ask me, Miss, why did you apply this? How did you know that that's what you have to do first? Any question like that, you have to ask me. Okay. Okay. So then let's look at number 3. Look at number 3. Give me a moment. Okay, sorry about that. Number 3. This looks like a very difficult question. I mean, the diagram might scare you. What's going on here, right? Do not worry. Connected particle questions are very straightforward. I mean, you because we have only a limited things to apply. You just apply them. You have to know how to mark forces, and you have to know how, especially when friction comes into play, you have to know about friction, in what direction to mark it and all that. So marking forces knowledge, and then in the direction of motion, F equals ma, in any direction that is in equilibrium conditions, the equilibrium, that's all you need to apply. But then you will get a set of equations. By solving those, you can find whatever they're asking. This is a summary actually. Okay, but from question to question, we just see how things are slightly different. It's the same thing. Okay, now this looks like a long. It looks long. The diagram looks a bit, I don't know, right? So shall we read this? I'm going to copy the, until you read it. Now, one thing that you know is that I have told you this too. The diagram itself tells you everything. So just study the diagram first really well. Look at the diagram. Two particles connected, pulley, both are on, like that. You confirm it to yourself. So this is horizontal, this is like that. Which is heavy? If are there friction? If it is just like that, in what direction will they move? Things like that. Just absorb all that. And in the body of the question, in all of this, they are only repeating that, all that information in the diagram, as I have told you. So you can skim through quickly, right? So while I give you a minute to read, I'm going to quickly copy the diagram onto my page. And I have told you in the note, certain information you can ignore in the beginning. Now they have given this 1 meter, this particle B is there 1 meter from something, fixed something there. So that, like, if this comes down, it'll hit that, right? There is like a, oh, how do you say it like that, right? There is like a wall here. Um, and hope you are doing, you're trying to do things with me, A and B. They've given how far A is sitting from the pulley, from the edge of that, the two surfaces, 2.5 here. and the masses are given and all that. Now quickly let's read through the body of the question. As shown in the diagram, A masses lies horizontal plane, particle P inclined 30 degrees. Particles are connected via light inextensible, passes through a smooth pulley, fixed at the top, inclined plane. Okay. Now they do not say, okay, they in the body of the question, they are not saying whether the surfaces are smooth or rough. Okay, so maybe it comes later, we'll see. Distance AP is 2.5. So yeah, they're repeating the same information. Bottom line 1. There is a barrier at the bottom of the inclined plane that we saw it. The part A of the is parallel. The whole thing. And finally, the last sentence only we need. The particles are released from rest with both parts of the string taut. So there is tension. It's pulling, right? You release it like this, just the way you see in the diagram. You release it, you keep it, you place the particles over the pulley on the two surfaces, and you release them, you let go. Okay, part 1. Given that both planes are smooth, stop right there. If the two surfaces are smooth, you tell me what will happen to this system. Will it move or will it stay like that? These two particles with the string, would they start to accelerate into it will start to move. In what direction? The obvious questions are asking. But all that they have to run through your head. B, towards B. Good, carving the heaviest weight, of course, right? It will go down like that. Okay, so what do we need to find? Given that both planes are smooth, find the acceleration of A and the tension in the string. Typical, how they typically start a connected particles question. And I have given you instructions in the note what to do, what we've been doing in the two questions we discussed. You start with free body force diagrams for A and B, and they are both accelerating with the same acceleration. You apply F equals ma in the direction of acceleration, and in any perpendicular direction, you apply conditions for equilibrium, and then solve these equations. That's all. Okay, shall we start? Okay, here I go. I'm taking you to the my paper. Is this screen dark? I feel like it's no. Let me know if there is any issue with the visual. Okay, so here's A. This is the actual diagram. I am now doing the free body force diagram. There's my A. So I just show the surface to just for my information that it is on a surface. Weight, how much? 16. Normal reaction are tension. That's all, right? And I will mark the acceleration on the side. It's accelerating that way. You get it? Oh, Malit, hi. It's okay. Malit is late. Long power cut. Okay, I will send you the recording. We just started number 3 in the worksheet. Then free body force diagram for B. Here's B. Here's B. I will just draw part of the flow, the surface, just so that I know. Okay, Malit. So again, you start with the weight, 24. Reaction, R. Tension, same T. It's the same string, same tension. Both particles would feel the same pull, same T, and this is moving this way. Okay, this is parallel now. Yo, my lines. It's parallel to the surface. Then for A, you can apply. Sorry, right? For A, you apply F equals ma in this direction. Shall we apply the condition for equilibrium first? I think that would be better because no, anyway, it's the same. It's the same. There is no friction. We are not going to need R here. Now that's another thing to think about. We would need R, the value of R we would need if there is friction happening here, because to calculate friction, you need R, mu R. Otherwise, we don't have to. Now, you can apply conditions for equilibrium this way. Then you would get R is equal to 16. But that information we don't need here. So I'm not going to apply it. I'm going to apply the F equals MA in the parallel direction, in this direction. F equals MA. I get, there's only T is equal to 1.6. It's 1.6? Yeah, 1.6A. Nice. I get an equation of A and T. Let me label it as 1. Then here, for B, again, I'm going to apply F equals MA in the direction of motion. Please notice how I always write to what particle, in what direction I'm applying F equals MA. You have to indicate these two. Okay, in that way, it's minus T. Before minus T, I can put the, let me put that first. The positive, there is a positive force. Oops. I think I just, what did I do? Okay. There is the component of the weight, that is 24, that is down the slope that way. I mean, that is something that you can do. You can remove the 24 and replace it with the two components in your diagram itself, if you like that, if you like doing that. This is 24, if that is 30, this is 30. 24, what is that? 24 sine.
Sine 30.
Thank you, Nathan. And this is 24 cos 30. So if you mark those two, this can be removed. I mean, you can replace with the two components. Now, it's 24 sine 30 minus t is equal to, what's the?
That is
2.4, no?
2.5 A.
2.4. 2.4a. Let me simplify the sine 30 is half. So that's 12 minus t equals 2.4a. Can you solve 1 and 2 and compute the acceleration and the tension and tell me what the answers are? Okay, A is 3. Malit says A is 3. Somebody confirm. Tension? Malit says 4.8. Yes, Hatri confirms. Okay. Clear, everyone? Shall we move on to part 2? So that's part A. That was quite easy. This is the typical question. This that they can ask in a connected particles question, acceleration and tension. So that's just doing that. Part 2. Let's see. 9 marks for part 2. Part 1 for what you did, 5 marks. You have earned 5 marks. Part 2, it is given instead that the horizontal plane is rough. The horizontal plane is rough. Now your free body force diagram will change. There will be additional forces for A. And that coefficient of friction between A and the horizontal plane is 0.2. Inclined plane is smooth. This is still the same. Find the total distance traveled by A. Find the total distance traveled by A. Now you might think, where do I begin to tackle this? What do I do? What should you do? You have to find the distance traveled by A. Thank you, Taridu. I'm just seeing your confirmed message. What would you do? What's the first thing you do?
Miss, can you repeat the question, Miss?
To do part 2, what should you do first? How do you begin that?
So it is given.
The first thing that you do. Is
The inclined plane is smooth. That's what they say. Yes, miss?
Yes.
So only the inclined plane is smooth. Yeah. Like you said, mark the new forces.
Right. So the forces acting on particle A, there would be an additional force acting on particle A.
That's friction.
Forces acting on B would still be the same. Uh, I have I have a question though. Would uh, would tension be the same now, or is it a new like?
It will be it will be different.
It'll be different, right? So it's a different tension. Tension would be there, but not the same thing as before. So let's start with drawing two new free body force diagrams. Okay, you do that again. So I will do for A first. Here's part 2. This is how you do clear. This is how you organize your work clearly, so that anyone can understand what you have done. So I'm redoing a free body force diagram for A. It doesn't take much time, but it's very helpful. You have the 16 that never changed. Weight doesn't change. R is there. I have to mark T. I can't mark it as 4.8. It's now different. Going to be different. And this would start to move that way, just like before. That will be a different acceleration. Now there is friction acting in the other direction. Is it maximum friction or some other friction?
Maximum friction.
Maximum friction, F max. Now you would need that R, right? So you would have to consider equilibrium in the vertical direction. Okay, here's B. B is on a slant, this thing. The components of the weight did not change. These are the component of the weight. This is 12 and this is 24 cos 30, whatever that is, 24 cos 30. Both these together represent weight. There is reaction, there is tension. It's the same diagram as before if you look at the previous diagram, and it's going to go down with the same this acceleration. Okay, and now begin by first applying for A. For A, let's apply vertical equilibrium, because you are going to need that when you do F equals ma this way. So let's do the vertical equilibrium first. Vertical equilibrium. R is equal to 16. Then we will do this way, F equals ma. My new F is, T is in the direction of the motion, so T is positive. T minus F max, I will first write F max and put the values in the next step. T minus F max is equal to, what's M? 1.6 A. And let me now put F max. F max is R times mu. What was mu? 0.2? Mu R equals 1.6a. That is T minus 3.2 is equal to 1.6a. Let me label it as 1. Okay. I have applied everything possible to particle A. Equilibrium I have considered, F equals ma I have considered. I go to B. For B, you can consider equilibrium this way. Let's just, you might not need it. We didn't do it earlier because there is no friction acting on B. We are not going to need R. But for the sake of completion, you don't need this step. Just for the sake of completion, I will just apply it. That direction equilibrium would give you R is equal to 24 cos 30, whatever that is. We do not need that. I'm telling you. But let's keep it, right? Who knows? At some point, what if we need it, then we can just use it. And then in the direction of the acceleration, in the direction of motion, F equals ma. That gives me 12 minus T is equal to 2.4 A. Number 2. Right now, what I did in the beginning of part 2 is the same thing that I did in part 1. In part 2, they are asking me a different question. They are not asking me to find A and T, but as if to find A and D, I did this. What am I trying to do? I am going to be needing the acceleration if I'm to find any distance involved with this motion, because they're asking me for a distance traveled by A. For that, you have to know that I'm going to apply equations of motion, and there I need the acceleration A. How do I find A? A comes from this. So can you solve 1 and 2? Solve 1 and 2 and give me just A. I don't need T. Answer for A? No, Malik. Kavindi is right. Hatvi is wrong.
Miss?
Yeah.
Is the answer for A 3.8?
Hatvi got the same answer. How do you get the same wrong answer?
Huh?
Yeah,
it's wrong.
Yes, it's wrong. How do you get 3.8?
No.
Okay, I will not say it. But Kavindi has written it. Everybody can say it. Malit says that you two discuss and do the same mistake. Okay, so the right answer is 2.2. Umalya got the same right answer. Good. I will write it here. Can you all check where you have gone wrong? It's supposed to be 2.2. What is this? Two simultaneous equations. You only have to add these two, isn't it? Add 1 and 2?
Yes.
Then what you said? It's 2.2. Ayyo. When you add 1 and 2, he gets cancelled. You get 12 minus 3.2. 12 minus...
I see my mistake. I see my mistake.
I mean, how do you did the same careless mistake to get 3.8? Anyway, okay, we found the acceleration. Now, I'm going to take you back to the main diagram. Please look at this diagram now, everyone. We have to find the total distance traveled by A. Now, I need you to visualize this motion that is going to happen here. B is coming down. A is coming with B. They are attached. They are moving together. Remember, A is 2.5 meters away from the what do you call it? The pulley, and B is 1 meter away from this barrier down at the bottom of the slope. Now B will come down. So when B moves 1 meter up to the barrier, A would also move 1 meter towards the pulley, and then B will hit the barrier. This is just like in the first question, one particle hits the floor, and what happens to the other particle? Same scenario, but it's in a different arrangement. They are not hanging. So B will go and hit the barrier. The moment B hits the barrier, we'll assume that it stops. But if the moment it hits the barrier, A will still keep moving, and the string will become slack and tension will disappear the moment B hits the barrier. So there are two parts to this motion. If you focus on the motion of particle A, first it moves while the string is taut. It moves 1 meter like that. That's the 1 meter that B moves till it hits the barrier. Then after B hits the barrier, after A has moved 1 meter, that point, the string becomes slack and tension is no more there. And particle A will continue to move because it was already moving. But now with the absence of tension, under the remaining forces acting on it, it will start to decelerate, to slow down and stop. So we only have to find that distance that A is going to travel, and we can add that one later. That would be the total distance traveled by A. Is this clear? Is my explanation clear? Did you get that? Okay. Now, so let's focus on, do we need to find the distance traveled during the string is taut? We don't. It's 1 meter. But we are focusing on the subsequent motion after B hits the barrier. Good, Nathan. After B hits the barrier, for that motion, while the string is slack, what do we know? We don't know anything. Now, what do we have to apply equations of motion. We need some information. What we want to find is S, distance traveled. We need 3 information to apply an equation of motion to find S. We have U, V, A, T. We need some information. Okay, final speed would be 0 until it stops. We want to find. Can we find the initial velocity? The initial velocity for that part of the motion would be the final velocity of the first part of the motion when the string is taut. Is that clear? So we have to begin from that part. So the first thing is the identification that there are 2 separate parts of motions to this problem. The part of the motion of particle A while the string is taut, where it moves 1 meter in that motion, and the second part of the motion is while the string is slack. So 2 different accelerations. It undergoes 2 different accelerations. So equations of motion should be applied separately. We know this. So I hope it's clear. Please let me know if anything is not clear. I'm going to go back to my paper. And in my mind, I figured out that I first need to apply equations of motion for the first part of the motion of A when the string is taut and when the acceleration is 2.2, what I found, to find the final velocity. Because that final velocity is going to be the initial velocity for the second part of the motion. Okay. So, sorry, let me drink some water. So I'm going to write for A, I'm applying equations for A. I'll say for A's motion, I'll say during or while during the string is taut, T-A-U-T. Okay. Oh, there's a weird creature that just flew onto my, oh, very good, my table. Putta, come and, oh, okay. There's a weird creature, Putta. Oh, I've not seen a creature like that in my life before. Okay. So what do I know about that part of the motion? I know A started with 0. I found the acceleration 2.2. I want to find V. I need one more information. I know this distance, 1. No, Malik. I would have loved if aliens landed on my table. Very funny. Okay, can you find V here? Did you see how I listed down my information? It started at 0. acceleration is what you found. And I know it traveled a distance of 1. V squared equals u squared plus 2as. I will not do this. You tell me what V is. What's V? Huh, that's fast. 2.1. Okay, exactly. If it's an irrational number, keep it as a root. Like, you know that if you get root 2 as an answer, you keep it as root 2 because root 2 value cannot be written down properly. Is this an exact answer? If not, give me it as an irrational number. Oh, Ayo, 110 over 5 is what, Malik? Root 110 over 5. Okay. Is that right? No, can't be. You sure? Can someone else confirm that? Okay, Kavindi. No, it's okay. I'm going to keep it like this. It's ugly, huh? 110 over 5, like that. Okay. How did it divide by? Okay, anyway. Right. Now, I'm going to now consider for ace motion during the string is slack. During the string is slack. And I'm going to write a list of information. I have to have 3 known information. What do I want to find? I want to find S. I will put S equals question mark first. Then I just found the initial speed. U is that. What else do I know? V is 0 until it stops. I need one more information, but I don't have any more information. I need either A or T. Now I want you to think along with me. What would your mind say? What would your brain tell you to do? I need time. I can't think of a way to find time. Can I find the acceleration? In some way, maybe. I need at least A or T. I need A or T. Is there a way to find A? Can I find this? Can I find this? So I have to find it and then apply these equations of motion. What do I do?
Acceleration is the same, right, miss? 2.2?
Oh.
No.
How is it the same? Now it's
no. Yeah, I get it. Yeah.
But can we find this new acceleration? Of course we can find it. Draw a free body force diagram for A. Now I'm keeping this here. I'm going back to A. I'm going to draw a free body force diagram for A when the string is slack now. I have my weight. How much weight? 16. Reaction, F max this way. No tension. And it's accelerating, the new acceleration. It was accelerating with 2.2 when the string is taut with when there was tension, and now suddenly tension was removed. Now acceleration will change because the resultant force is now different. I can find it. So find it on the side. So this is actually happening in the bubble on the side. You apply F equals ma this way. The only force is F max. Would F max change? Would R is still 16 and then F max is the same, right? You have to argue like that. R has not changed. R is equal to 16. Mu is the same mu. The surface didn't change. So what was F max before? 3.2. 3.2. This F max is 3.2 equals 1.6A. You can very quickly in this bubble, find A and put it here. How much is A? Yes, Mali. What's A? Minus half. Minus. Oh, wow. Minus half? No. No, wrong. Yeah. Minus 2. It's decelerating. It's minus 2. Now, I found this. Can I find this? Yes, I found it. It's minus 2 is equal to minus 2. I will put it like that. That shows how my thinking went. I first wrote this list of information I knew, and then I realized, I can't do it. I need A or T. There is. So I found it and I put it here. Now you apply what? Please grad. Whose microphone is that? And can you tell me what is this? Microphones mute, please. A is minus 2, not 2. Oh, let me see. Good question. I think that's O. Who is this? Oh, Madara, hi. Madara, you have to rename your profile, Zoom profile name with your name. Okay, you can't have robotic names. I mean,
no, sorry, Miss, I'm not using the lap. I'm using my mobile phone.
Okay,
So,
that's fine.
That's why.
That's okay. You should have in the beginning itself declared that hello, this is Madara. It's not Huawei. It's not some kind of.
Okay,
Yeah, just joking, Madara. Okay. Right. So that's Madara.
okay, me.
But we do notice if there is some unknown, like unidentified flying object. Right. Okay. What's S?
For this 1.1.
Huh? Yes, good. S is 1.1. Now can you tell me therefore the total?
Yeah, 4. It is 1.1 plus 1.
Very good. Therefore, total distance traveled by A is it traveled 1 meter as B went 1 meter down. Along with B, it also went 1 meter, and then it subsequently went 1.1 meters.
2.1.
It's 2.1. Very good.
Meters.
Therefore, total distance traveled by A is 1 plus 1.1, 2.1 meters. Did everyone understand that? Yes, no, maybe. Okay. Yes. Okay, great. Right. Do you need time to write anything down, or can I change the screen back to the question? Do you need the screen? Some more? I'll wait a bit more. Okay. Let's go back to the worksheet. That was 9 marks. Do you see that it is worth of some marks? I mean, because we did it, we had to analyze what's going to happen here. The particle A was undergoing 2 types of accelerations. First part when the string was taut, and the second part when with the string slack, and all that. So it was a lot of analysis and clarity in mind you have to have to tackle this. right? I hope you understood that. Okay, let's look at number 4, the short question, no diagram. Let me see. Let me see whether I can let you do it on your own. I think so. I think so. Do it on your own. I will wait. I will give you. It's just 4 marks. It is not even worth the marks. The part 1 of the previous question had. It was 5 marks. You can tackle this very easily. Now, take this as a not a challenge, but take this as an opportunity for you to assess yourself. Can I tackle a simple, fairly simple question related to connected particles? Can you do this? So follow the steps that I've given you. Present your work methodically in an organized manner. Uh, these questions always have 2 particles. Do their work side by side. It's nice and it's very clear. It gives clarity to your mind as well when you do it side by side. At least to me. I don't know. So I will stop now. You give me the answers in the chat box. When you read this question and thought about the arrangement of these particles, did you have any questions? Oh, they haven't told us whether. Did you have any questions like that? Did you feel like?
No.
No. Okay, great. Others? No one felt like that? No one felt the need of another information? Okay. Hatfi, you're right. So Hatfi has given the answers. Kavindi, you're right. Acceleration, Kavindi? That's correct. waiting till others drop their answers too. That's right, Malik. Why? How is it obviously? Because it's, yeah. I'm sorry. Yeah, I'm sorry. I was asking for A. I didn't, yeah. It's a show question. A6. I'm sorry. I don't have to ask you for A. Just find T. Okay, so Malik is correct too. Sorry that I'm yawning. At least 2 more people have to give me their answers. If I call out a few names, let's see. Bimandi, Joanne. So we have all the girls here today. Rachel, Madara, Amalia. Nice to have you all here. I would love to. Kavindi usually responds and gives answers and all that. There are interactions. Other girls, I rarely hear from you, which I don't like. I need to hear something from you. Are y'all still doing? I mean,
Almost done.
Almost done. Okay. I hate to press you. The only reason I'm pressing is because I just need to try and get as much work done during the time that we have. But as I tell you, when you're doing it leisurely, just take your time and do it. Okay. What you have to do is do it somehow correctly. But in a way, this is a simple question. So if you're taking too long a time, that is a concern. Just very straightforward and very simple.
Acceleration is Natalie.
How much?
May I tell the acceleration answer?
Don't acceleration. It's there in the question. Nathan, drop a message privately to me with tension value.
Oh no. Oh no. Oh God. Why?
Why, Nathan? You didn't get sick.
I didn't get the acceleration correct. I have gone wrong in life.
Check. Girls, other girls? Rachel, Madara? I don't want to just reveal you the answer. I want you to get it. Bimandi, Joanne? What's going on? What's happening now? Are you still on it?
Yes. You called my name?
No.
Okay, sorry. I must be dreaming.
Yeah, you are dreaming. I said Bimandi or Joanne?
I went out to drink some water and then I thought.
Hot. Okay. Bimandi, Joanne. That's correct, Nathan. Very good. So far, Hatfi, Kavindi, Malit, and Nathan have completed it. Okay, Bimandi, thank you for letting me know. She's still doing it. I'm wondering whether you are maybe on a wrong track. It shouldn't take so long. This is similar to the first question we did. The two particles are just hanging over a pulley in air. They're hanging in air. They're not resting on any surface. And then they will start moving towards a heavier particle. And the only forces acting are the weight and the tension. You just apply F equals ma in the direction of motion, and you get two pairs of equation of A and T, and you solve them. Joanne, yes, Joanne, you're correct. I feel very happy. So can you please drop your answers? I feel very happy when you get the right answers. Oh, wow, I can see how people's internet connections keep dropping. The number of participants keep varying, so your connection, yeah, Madara is no more with us here now in the lesson. Rachel has disappeared. I hope they will come back. Okay, Bimandi, Mihil. Where's Mihil? Mihil is also gone. How about Tarindu? Tarindu, you also have been very quiet lately. I will wait for one more answer. Only one more answer. A lot of time has passed.
I'm not at home. My signal is not very good.
What's that, Tarindu?
I'm not at home, so my signal is not very good.
You are not at home and your signal is not very good?
Yeah.
Signal is not very good.
Signal. Okay, Tarindu, okay. Tarindu, if you have the answer, is it possible to drop the answer? Rachel is back. How about Umalya? Umalya, did you give the answer? Bimandi. Yes, Bimandi, that's correct. So majority has given me the answers. It would have been great if all of you could give me the answer before I showed it to you. But I think it's a bit too long, that the time that you took. Here's the work. Here's how you should start. Very two simple free body force diagrams, A and B. You have weight and tension for both acting. A is heavier, so it will come down towards A. A is moving down, B is moving up. The information that you might think that you needed, none of you thought about it. I don't know whether anyone was thinking, are they kept in the same level, or is it, we don't need that information.
It doesn't matter.
Yeah, it doesn't matter. Very good. Yes, it doesn't matter. So you just, whatever the way they were released, they will start accelerating like that. So you apply F equals ma to A, F equals ma to B. You get two equations of A and P. You solve them and you get your answers. So straightforward, so easy. Or see how many steps there. It's just 4 marks. So 4 marks means it imposes a certain time duration on you. When it is 4 marks, you can't take like 15 minutes to do it. That's a thing. Okay. So the weight of the marks gives you an indication of how long you should spend on it. If it is taking you too long, you're on the wrong road. So you have to know that. Okay, let us go to the next question. And this time, it is not a simple one, but I am going to let you do it again. This is how you will learn it. If I just show you again how to do it, you would be just sitting back and like watching a movie. You'd be just waving your legs and watch. I don't know. I'm just thinking. Okay, you might be just watching how I. No, I want you to get your minds start thinking and start working on this. So can you start this? I'll let you start it. I'll let you work on it. After some time, once you have dived into it and struggled with it, I'm sure it won't be a big struggle. But after you have done that, you have experienced the problem yourself, then I will join. Okay, so here's the question. Read, absorb the diagram, and start working on it.
Teacher, where's Malli?
He's here. Puta, here Nathan Aya is asking for you. Come and say hi. Papa, he's very happy. He's very happy. My.
Hello.
Say hello, Puta. Hello. Hello, Ayala. Akkala. Wait. So say it. Say something and go. Would you like to see their faces? No? Yeah? Okay, so let's see who can show their faces. Put this. That is his name. Pramindu is his name. Yeah. Wow, Malit. See, Malitaya, he can't read. So Malitaya is typing, hello, Pramindu. See, they can remember your name. Let's see.
Hello.
There's Nathanaya. Papuisha. Where are they going? Okay. Go down. Okay. Thank you for that, everyone. You know who that is, right?
Yes.
Who?
Your nephew.
Yes. Okay. Are you working on the problem now? I'm sorry for distracting you, but I'm sure that it was a good distraction. Now I can see that Nathan is good with kids. And Malik too. Okay. Back to the question, everyone. Focus now, okay? Focus on the question now. Because this arrangement of the particles is new. We had a case where one particle was on a slope, on a surface, and the other particle was hanging in air. Let me take you to that. But in this one, right? Here, particle P is on a slope this way. Now the slope is, it's an upward slope, not a downward slope. And I hope you took notice of the last line here. They say the system is, now when you leave it,
Limited equilibrium.
it's in limiting equilibrium. It's about to move, but it's not moving. It's about to move.
F max.
F max, and also forces are balanced because it's not still moving, but the friction is F max. Good. I'm sure you can tackle this problem. So let me know if you get part 1 answer. You're finding mu. Whatever you have to find, what you have to do is the same. You draw free body force diagrams, you apply, if your system is in equilibrium, you apply conditions for equilibrium for each particle. If your system is moving, you apply F equals ma in the direction of motion. That's it. And then work with these equations. That's it. So until you find mu, you take mu as mu. If you need mu in your equation, uh, you take it as mu, and mu is what you have to finally find. And here there is another unknown m. I'm sure you don't need m to find mu. That's why it's not given. So you take it as m and go ahead with it. And you will see at some point m will cancel. How is it going?
It's going all right.
Okay, good, good. Let me know as soon as you find the value for mu. Can someone tell me In what direction friction is acting on P?
Upwards.
Very good. Are you close to getting the answer? Are you close to finding mu? Because I can't see.
I don't know. I just end up going in circles.
You shouldn't be going in circles. You know what to do. You draw.
Yeah, I know. What's this? Miss, can I show you can I show what I did so that so that what's this? You can see where I went wrong. Or should I send it through WhatsApp? Oh no, you can't. No? Because you're using the IV cam.
But I can. That also is hard. I can check it on my laptop. I have WhatsApp on my laptop, other laptop, but it's hard to like refer to it.
It's okay, Miss.
Okay, so if I just tell you now, all of you, just see whether you have gone down these steps. First step, make sure that you have drawn two free body force diagrams for P and Q. I will show that step only. Okay, let me show you what this. Here's your free body force diagram. This is how it must look like. So you can check whether that part is correct. Here are the two free body force diagrams. Do you have that right?
Oh, I not mentioned tension.
Without tension, how can you? Connected particles, tension. Like
right.
Connected particles.
Oh no! Why?
So, did you have Q only with one force acting on it? If no tension, do you have only weight acting on Q in your diagram?
No.
That can't happen there.
I have forgotten to mention T on the other one. On P.
Here.
Yes. That's where I went wrong.
Others, have you gotten the diagram correctly? Then you apply Newton's first and second law for particle P in the vertical direction. This way, forces are balanced. R is equal to 10m cos alpha. And then this direction, again, forces are balanced because it's in limiting equilibrium. So T plus 10m sine alpha is equal to F max. And F max you can write in terms of R and mu. And then if for Q, you apply equilibrium, T is equal to 10. So you immediately have the value of T. T is 10m. Okay, so Malit keeps getting -3/4. It's just a sign error. Okay, so let me reveal step by step. What is I mean, I have found the F max first. Did you get 9.6? They say it's 4/3. No, let me do it. I have this. Let me just do it here. We don't have much time left, but let me use these two diagrams. Okay. So for P, if I apply equilibrium this way, I get R is equal to, so I've taken mass to be M. So mg is 10m. You could have said mg. I'm just saying 10m. 10m cos alpha. I have, so they have
Miss?
tan alpha is 7 over 20.
Yeah, I did that and I got cos alpha as 24 over 25.
That's correct. So that is 10m, 24 over 25. So that's R, okay? Then if you apply equilibrium in this way, you get T is equal to, so T plus 10m sine alpha is equal to F max. T
versus T plus mg, the sine alpha equals 7 over 25.
Good, that's correct, 7 over 25. And F max I can write as R, mu R, so mu, and R is this, 10m times 24 over 25. Let me keep it like that. That's all I can do with particle P. Then I go to particle Q. For Q, vertical equilibrium, and I have T is equal to 10m. I can use that here. Don't draw like that. Hatsi, yeah, Hatsi. I'm so happy. Hatsi got the answer. So I want you to get the answer without me showing it. Right?
Oh, that's strange.
It's a great feeling.
Miss?
Can I stop here at least? I mean, let me not do all the way.
Miss?
Yeah, okay, sure. I'll give you time. Mali, please, for 2 more minutes. Yes, Nathan.
Miss, was this now?
Oh, give me a moment. Wait. Before we do anything, my battery is low. I have to plug this in. Give me a moment. I'll run down and get the charger. Before this will go off.
All right. So basically, how did the coefficient of friction get removed from here? Hello, anybody? Okay, now we have already the equation 10 t plus I wrote as mg into 7 over 25, and the other side wait, you lost me.
I am back. I'm sorry.
Okay.
Great, you're discussing great. I like this. Okay.
Miss, so my question here is, Miss, now we have this equation. I wrote this equation. After, Miss, how do we get how did that become t equals 10m, Miss? Because there's a mu, right? Sorry, not mu. The coefficient of friction we found, but how did you get t equals 10m there?
This is for Q, vertical equilibrium. Look at I'm applying for Q now. Q.
Oh, okay.
You forgot Q.
Okay.
There are two verticals.
Never mind.
You got it, Malik? Great. Don't you feel good when you get it? Okay. Girls, did you get the answer? Any of the girls?
Everything is so clear now. I see the answer.
There will come a point you feel that I got the hang of it now. I know like how to.
I wouldn't say everything in life is good. I wouldn't say everything is good. I'd say there are.
Girls. Can one of the girls respond? How is it going? Like I've now shown you half of 3/4 of the work. 90% of the work is already there. You just have to now put this T here and then make mu the subject. So it's a lot of it is manipulating this. You apply the conditions, you get different equations, and you have to combine them. I get rid of that. Let me put it here. In order to get to what they're asking you to find. No one is saying anything, girls. Joanne, great. Joanne got it too. I am very happy. Okay, I'm going to still trying. It's fine, Kavindi, Umalya. Okay. Okay, so what I will do is I will take you to back to the question. And I'm going to leave part 2 for you to do. Okay, to find the value of m. They have given some things, and also now you all have this worksheet, right? You all have this.
Miss, what
Yes.
did I miss?
What? You didn't miss anything.
Okay.
So part
Miss,
2 I'm going to leave for homework. Yes, Nathan.
Miss. Okay.
Yes.
What's this? Now we know for that vertical equilibrium of for Q, that is 10m, no, Miss?
T is equal
So
to
when I substitute that to that previous equation which we formed there, that is 10m plus 10m into 7 over 25. No, so the other side also has
you look at
10m.
the screen, it's there.
Yeah, so I can cut off 10m from both sides.
Yes, 10m from everything. From each term. That is, you're dividing the whole equation by 10m. So 10m, 10m will take off. Now, Nathan, so do it leisurely. You're there. Okay. So what I was saying was, I'm leaving part 2 for homework and also number 6 for homework. Is that okay? Number 5, complete number 5 and number 6 for homework. Okay. Next week we will do like 2 more in the class with me. We'll try 2 more, and then I will leave the rest for you to do. I'm sure by next week you'll be okay with it, and we will start the next topic in mechanics. Okay. Right. We will wind up with that. And as I have said in the WhatsApp group, we have to